Welcome everyone. I'm Kimber Scavo, Group Leader of the State and Local Programs Group in EPA's Office of Air Quality Planning and Standards. We are glad to be doing this broadcast on the implementation rule for the 1997 fine particle standards. The rule was published in April 2007 after considerable discussion and review. The presentations to follow are given by Rich Damberg, Team Leader for Particulate Matter Implementation Programs, and by Tim Smith, our National Expert on Particulate Matter Control Technologies. The presentations are similar to those that were presented at a national workshop sponsored by EPA in June 2007 in Chicago. So why is this an important issue? Among the criteria pollutants, PM2.5 has been shown to present the greatest health risks. The first state implementation plans to reduce fine particle levels are due next April in 2008. These plans need to attain the 1997 standards as expeditiously as possible to protect public health. A number of EPA's national rules are in place to reduce emissions from power plants and mobile sources, but local and in-state sources are responsible for a significant portion of the fine particle problem and health risk as well. These sources are the focus of the state plans to attain the fine particle standards. The PM2.5 implementation rule provides the framework for a process that states should follow for evaluating emission sources and potential control measures, identifying the most expeditious attainment date for an area, and adopting required control measures. Rich Damberg will start off with an overview presentation on the April 2007 implementation rule. So with that, I introduce Mr. Rich Damberg.
Today's presentation is on the Clean Air Fine Particle Implementation Rule for the 1997 PM2.5 standards. I'm going to talk about some background about fine particles and sources of fine particles, and then I'm going to talk about the elements of the rule in some overview, and then we will be talking we'll have other presentations discuss those in more detail. Fine particles are a complex mixture of extremely small particles and liquid droplets. The larger particles, which are greater than 10 microns in diameter, deposit in the upper respiratory tract. Smaller inhalable particles that are smaller than PM10 penetrate deeply into the lungs. Both coarse particulate matter and fine particulate matter can penetrate into the lower regions of the lung. Some particles accumulate, some react, and others are cleared, and in some cases, particles can pass into the bloodstream. The main components of particulate matter can be categorized into fine and coarse categories. Fine particles typically result from the combustion, high temperature combustion in industrial processes, power generation, the combustion of diesel and gasoline in mobile sources, combustion of wood for residential heating, and also from forest fires. The emissions from such combustion are typically sulfur dioxide, nitrogen oxides, organic gases, and some crustal material also contributes to fine particle concentrations. The exposure and lifetime of such particles is on the order of days to weeks, and the transport of these particles can be on scales of thousands of kilometers in some cases. In terms of coarse particles, those typically result from crushing, grinding types of activities, as well as from dust from disturbed soil from construction or roads and that kind of thing. Coarse particles have a much shorter transport distance and a much shorter exposure time. Now, the public health risks with fine particles are quite significant. Some of the effects that are linked to fine particles are aggravation of heart and lung diseases, things like aggravated asthma, increases in respiratory symptoms like coughing and difficult or painful breathing, chronic bronchitis, decreased lung function, and even premature death in some people with heart and lung disease. The exposure to fine particles leads to increases in hospital admissions, doctor and emergency room visits, increased medication use, and thousands of days per year in terms of absences from school and work. Research has shown that some groups are more at risk for exposure to fine particles. And those are people with pre-existing heart or lung disease, older adults who have a greater prevalence of heart and lung disease, as well as children who are more likely to be active. They breathe more air per pound of body mass, and their bodies are still developing. Now, the 1997 standards were set at an annual level of 15 micrograms per cubic meter, and the 24-hour level was set at 65 micrograms per cubic meter. These are both averaged over a 3-year period. The 24-hour standard has a 98th percentile form. The standards were recently revised in 2006. The annual standard remained the same. The 24-hour standard was reduced from 65 to 35 micrograms per cubic meter. Now, the attainment of these standards in terms of benefits and costs are quite significant. In 1997, when those standards were set, the estimated monetized benefits from attaining those standards nationally ranged up to $100 billion per year and up to 15,000 incidences of premature mortality avoided, as opposed to costs on the order of $8 or $9 billion per year. In 2006, the recent economic analyses for those standards showed that the incremental benefits on top of meeting the 1997 standards, and this is from going from a 65 to a 35 24-hour standard, ranged from $9 billion to $75 billion incrementally in terms of health and visibility benefits by 2020, with a central estimate in one study of around $17 billion per year. The cost estimate is $5.4 billion per year in 2020. So the main point here is that the benefits greatly exceed the costs in terms of controlling fine particles and attaining these standards. In terms of benefits per ton of reduction of pollutants associated with fine particles, they are often in the tens of thousands, sometimes hundreds of thousands of dollars per ton. This table shows milestones for implementing the 1997 and the 2006 fine particle standards. For the 1997 standards, that's primarily what we're talking about today. Designations occurred and were effective in April of 2005. State implementation plans are due 3 years later in April of 2008. Attainment dates are to be as expeditiously as practicable, but no later than 5 years from the date of designation, and that puts it to April 2010. Although attainment date extensions may be possible up to April of 2015, and I'll be talking about that more a little bit later. For the 2006 fine particle standards, the designations are to be completed no later than December of 2008. The effective date is typically another 90 days beyond the publication date, so that could be somewhere in the spring of 2009. So for the 24-hour standard violating areas, you would see SIPs being due in 2012, and attainment date no later than 5 years after the effective date of designations. That could be 2014, and then the attainment date with extensions could be another 5 years beyond that. Now, there is a possibility that the designations could take an extra year if the administrator deems that there's insufficient information to finalize the designations in 2008. But we will see what happens there. The next slide shows the areas that were designated in 2005 as non-attainment for the 1997 standards. We've got 39 areas. 3 are in the west and all the rest are in the east. In the west, you've got a small area in Montana, Libby, Montana, and San Joaquin Valley and the South Coast area in Los Angeles. As you can see, most of these areas are in the east. The total population is on the order of about 88 million people in these areas. Now, when we look at the most recent air quality monitoring data that we have for 2004 to 2006, we see the red areas, which are currently designated non-attainment for the annual standard. They indicate the areas that are also violating the 24-hour standard, which was recently finalized. You can see 10 areas in blue, and those are all in the east. Those are areas that violate the annual standard but meet the 24-hour standard at this time. Then there are a number of dots that are black dots showing other sites that violate the 24-hour standard based upon these 3 years of data. We are looking at this data. We're also looking at the data from 2003 through 5 to see what areas will be candidates for designations in 2008. If you go to the next slide, this shows the combination of areas that were exceeding the 24-hour standard, either for the 2003 to 5 period or for 2004 to 6. These amount to an additional 69 sites, and so we will be keeping track of these sites as we move closer to the designations. Now, one thing to keep in mind as states are planning for the current state implementation plans, we're focused on the annual standard. However, if an area is also violating the 24-hour standard, keep in mind measures that could be addressing source categories that are also contributing to these high 24-hour concentrations. Now, there's a few areas in the states that were designated attainment in 2005 but are now violating for the annual standard. And we recommend that the states work with the regional offices to achieve clean air in these areas. And some of the approaches that have been used in the past are voluntary measures, memorandum of agreements, working with stakeholder groups. In some cases, it has led to a SIP call or designation to non-attainment, but we feel that some of these situations can be addressed without going to those steps. Now I'm going to go through a number of the elements of the fine particle implementation rule. The first element is what pollutants are to be addressed in the attainment plans. And the rule has policies for the main precursors and for direct PM 2.5. For direct PM 2.5 and for sulfur dioxide, the policy is that states must evaluate sources for control measures of both of these pollutants. And these need to be evaluated in each area. For sources of NOx, state must evaluate sources of NOx for control measures in each area unless the state and EPA provide a technical demonstration showing that NOx emissions from sources in the state do not significantly contribute to PM concentrations in the specific area. In terms of VOCs, the organic carbon component of ambient PM 2.5 is a complex mixture of hundreds or even thousands of organic compounds. High molecular weight VOCs condense readily when emitted into the ambient air and are considered direct organic carbon particles. Other VOCs react in the atmosphere to form secondary organic aerosols. While there's been significant progress made in understanding the role of gaseous organic formation of organic PM, this relationship remains still very complex. And for this reason, the policy is the reverse of the policy of NOx, which is that sources of VOC are not required to be evaluated for control measures in each area unless the state or EPA provide a technical demonstration showing that VOC emissions significantly contribute to PM concentrations in a specific area. Ammonia reacts with sulfuric acid and nitric acid to form ammonium sulfate and ammonium nitrate. it's a key contributor to high PM levels in the wintertime when ammonium nitrate formation is favored by low temperatures and high humidity. However, emission inventories of ammonia are uncertain. There's a significant amount of research underway looking into this from animal feeding operations and other sources. And for this reason, the policy for ammonia is that states do not need to evaluate sources of ammonia for control measures in each area unless the state or EPA provide a demonstration showing that in a particular area ammonia emissions significantly contribute to PM concentrations, and also that reductions of ammonia would lead to significant reductions in fine particles. The rule also provides basic guidance on analyses for doing such technical demonstrations, and what we're looking at is basically a weight of evidence type of demonstration involving different kinds of analyses, looking at air quality information, emissions modeling, and so on. Now, in terms of when state implementation plans are due and attainment dates, SIP revisions are due in April of 2008, and in those plans, states should account for significant air quality improvement that is already being achieved from regional and national rules, such as the Clean Air Interstate Rule, different mobile source rules that are controlling diesel emissions, and so on. And then evaluate controls for local and in-state contributors to the problem. This is all designed to adopt reasonably available measures to attain as expeditiously as practicable as required under the Clean Air Act. And these SIPs should include enforceable emission limits and source testing and monitoring procedures as required. Now, attainment dates are to be no later than 5 years from the date of the designation, meaning by April of 2010, and extensions of 1 to 5 years are possible considering the severity of the non-attainment problem and the availability and feasibility of air pollution control measures. I will talk about this a little bit later in a following presentation on types of non-attainment areas and defining attainment dates. Attainment will be evaluated based upon the most recent 3 years of monitoring data. So for an April 2010 attainment date, we would be looking at air quality information for the years 2007, 8, and 9. Under the Fine Particle Implementation Program, there is no classification system as there is for ozone. The Fine Particle Program is implemented under Subpart 1 of the Clean Air Act, which provides more general provisions, but the final rule did not include a classification system. So for non-attainment areas, states need to adopt all reasonably available control measures, including reasonably available control technology, needed to attain the standards as expeditiously as practicable and to meet rate of further progress requirements. This analysis needs to be a collective analysis and to show that that there's no reasonably available additional measures that would advance the attainment date by a year. Tim will talk about these provisions in much more detail in a later presentation. So the guidance in the rule discusses technically and economically feasible measures, how to identify those, how to conduct air quality modeling, and how to select RACT and RACM measures. Each area has flexibility in terms of not having a tonnage threshold for evaluating sources. Areas with a more severe problem may need to evaluate smaller sources than an area with a less severe problem. And the preamble includes a list of specific measures that states should consider as a starting point for RACT and the RACT-RACM assessment, and Tim will talk more about that as well.